All right, let's jump straight into this explainer and rescue a failing physics 0625 answer, zero fluff. Look, if you're gearing up for your Cambridge exams, you already know the margin for error is just incredibly slim. Picture this, you're sitting right there in the exam hall, the clock is relentlessly ticking down, and boom, you hit a high-mark structured question on forces in motion, specifically free fall. You probably think, hey, I know this, but honestly, the way you actually structure your answer on that page is going to be the difference between securing that top band and walking away totally empty-handed. We are going to fix that exact problem right now. Ouch. The brutal reality here is that losing marks on a foundational concept like this creates a massive grade boundary risk. Seeing a giant zero on a major question, well, that's a confidence shock that can completely derail your entire paper. Now, examiners aren't sitting there trying to trick you, I promise, but they are actively hunting for a very specific logical sequence of scientific reasoning. And what happens? Students panic. They completely abandon their reasoning and just start throwing every memorized fact they know at the page, just desperately hoping something sticks. But in Cambridge IGCSE physics, isolated facts absolutely do not score the big points. Cause and effect does. And this right here perfectly illustrates a painfully common, flawed exam mistake. This is where ordinary, panicked, rote revision completely falls apart. You see an object falling, you know it's moving, so your stressed out brain immediately reaches for the most basic motion equation you can possibly think of. Velocity equals distance divided by time. Honestly, it's the physics equivalent of panicking and just writing your name as the answer. Just think about what changes physically during free fall. The velocity isn't constant at all. The object is actively accelerating. Slapping down a basic speed equation here basically proves to the examiner that you've totally misunderstood the core phenomenon. Rote memorizing formulas without understanding the real-world physical context is a huge trap. So instead of guessing, we're going to replace all that blind memorization with our concept-first framework. It's a crystal clear, logical sequence that actually builds a perfect Cambridge-style answer. This is your new game plan. Every single time, you follow these 4 steps. First, you identify the exact phenomenon. Second, you state the relationship. Third, you explain the underlying physics using a solid cause and effect chain. And finally, number 4, you connect it to an actual application. It's a total game changer because the absolute best exam answers always demonstrate both a deep fundamental understanding and a practical real-world application.
Now hold that thought. In just a second, I'm going to reveal the exact examiner clue that changes this entire answer completely. But honestly, to even spot that trap, you absolutely need the framework that makes the clue obvious in the first place. So let's start at step 1.
Applying that first step of our framework, we have to actually define free fall. And we do this by moving away from everyday, casual language and straight into precise physics vocabulary. It's not just falling down, right? It is the motion of an object subject only to the influence of gravity. Literally just gravity. This means, for a moment, we're completely ignoring air resistance, so we can understand the pure principle at play. And what's the actual result of that gravitational influence? Constant acceleration. The velocity is increasing uniformly over time. Notice how we are meticulously locking down the exact definitions here? That right there is the absolute foundation of your first principles explanation. So the really crucial point here is asking yourself a challenge question. This makes the whole concept feel totally necessary, and it helps you reason your way through those weird, unfamiliar exam scenarios they love to throw at you. I mean, why do we even care about free fall? If a teacher just scribbles equations on a whiteboard, they feel kind of decorative, right? Easily forgotten. But think about it. Keeping a multi-billion-dollar satellite in a stable orbit, or calculating the life-saving impact force of an emergency dropped package, all of that depends entirely on understanding this one concept. Once you realize that, it completely anchors the idea in your mind. You become way less dependent on memorized textbook wording and so much more adaptable under pressure.
Okay, look at that number, 1. Notice the absolute restraint here. We introduce exactly one symbolic relationship or equation, and we only do it when you are truly deeply ready for the underlying physics. Dumping 5 different equations onto the exam page? Yeah, that's a classic flashing red sign of panic. You want to cherry pick the one equation that perfectly maps to the physical change that's actually happening. So for free fall, you might pull in the acceleration of free fall, good old G, or relate it to force and mass. But the real secret here is restraint. State one relationship clearly, define your variables, and be fully prepared to explain what those variables actually mean in the real physical world.
This brings us to step 3, building that required cause and effect chain. Listen, explaining the physics step by step is exactly how you hit those top band mark schemes. You don't just lazily say it falls fast. No way. You state, the gravitational force acts downward on the mass. Boom. That's the cause. Therefore, the object experiences a constant acceleration. Right, that's the immediate effect. As a result, its velocity increases uniformly over time, and that is the final observable phenomenon. It's like a logical puzzle coming together. If the exam question happens to involve graphs, this is exactly where you emphasize what the slope or the shape actually means physically. Moving to step 4, you absolutely must be able to name at least one real-world situation outside the four walls of your classroom where this concept actually matters and explain how the physics improves the outcomes. Ideas from freefall are literally everywhere. You could be talking about designing transport safety systems, calculating orbital paths in astronomy, engineering massive drop towers for energy systems, or even calibrating highly specific medical tech. When an examiner asks you to describe a practical use, you now have this whole menu of awesome options ready to go. You state the use, and then, here's the kicker, you justify the link using the exact cause and effect chain we just built. All right, let's dive into an escalating challenge here. This is where students frequently, and I mean all the time, fall right into the examiner's trap despite actually knowing the topic. You've got the knowledge now, but let me tell you, the way you deploy it under intense pressure is everything. Let me let you in on a little secret. The mark scheme is ruthless here. A super common weakness is quoting a process without ever linking it to a physical effect. The examiner is actively testing you to see if your knowledge is just a fragile house of cards or a deeply, truly understood concept. Check this out to see what I mean. Imagine a flawed approach where a student just writes down F equals mg and entirely stops. Absolutely zero explanation. Well, the examiner literally cannot award high marks for that because you haven't shown any actual understanding. Now, contrast that with a top-band approach. Here, you use F equals mg to actively explain that because the object's weight, meaning the gravitational force, is constant, it therefore causes a constant acceleration, assuming the mass remains constant too. You are brilliantly linking the equation directly back to physical reality. That is the examiner clue I promised you earlier. Always, always link the raw formula to the actual physical behavior. So before you even think about turning the page in your revision notes, you need to answer these 4 quick recall prompts out loud. Seriously, say them aloud to ensure the topic is totally secure in your brain for those structured questions. Number 1, what is the core idea? 2, what changes physically? 3, what quantity or graph actually shows it? And 4, where is it used? If you can articulate these 4 answers clearly and confidently, my friend, you have mastered the free fall fundamentals. You've officially moved from a fragile, rote-memorized state into an incredibly robust, concept-first understanding that can withstand any weirdly phrased Cambridge question they throw at you. But wait, here is our massive, unresolved problem. You might know this concept-first strategy inside and out now, but do you have a specific timed answer writing system to actually finish the paper? I mean, it is fantastic that you can now construct this beautiful cause and effect top-band answer. But what on earth happens when you only have 3 minutes left on the clock to write the whole thing down? Knowing the physics is honestly only half the battle. Executing it under extreme, sweat-inducing time constraints is the true test of an elite student. How do you format all these brilliant thoughts quickly enough without losing your logical chain? While the full rescue kit continues as we solve that exact timing gap in our next explainer. So definitely remember to subscribe to our channel, Ace the Exams, at Ace the Exams IGCS to totally excel in your Cambridge examinations. We are going to take this exact structural framework we just learned and turn it into a lightning-fast, high-scoring writing system. But until then, I want you to ask yourself this one thing. If you perfectly understand the intricate physics of the entire universe, but you can't communicate it before the exam clock runs out, do you truly own that knowledge? Don't leave your final grade up to chance. Master the clock, and we'll see you next time.